So we are passing it into this function, and this function now check with this comparison operator. So a comparison may give you false or true. Okay, and if it gives you true, you keep that element. If it gives you false, you throw that element. You just throw it away. You just discard it. Okay, remember that. So for 0, again it is false, so you just throw 0. For negative 111, it is again false, because in this function the current value is negative 111, and you check is 111 more than 0, you get a false, so you just remove this one. For this one you get a positive, I'm sorry, for this you get a true value. For this again you get a true. So wherever you get a true, wherever, for every element, wherever you get a true, you keep that element, and wherever you get a false, you throw that element. You do not take that element. Okay, so this is how filter function works. Okay, and you can let's say let's write another example. Now let's have a list. Well, you can use tuple or set, whatever you like, but I personally prefer lists. I love lists because it is the most handy collections I have ever came across. And then you say, and you know instead of filter, you could have said like this. Let's say you have this one stored somewhere. So what if you wouldn't have used filter? Let me show you. So this is your original list. Just remove this demo. Let's say original list. Okay, and then you have another list, and you say new list, and you keep it empty, and then you start a for loop for um, number in original list if num more than 0, new list dot append num. And now check the elements of new list, print new list. So again you get the same result, but you are you are just look at this. You are writing 1, 2, 3, 4, and 5 lines of code just to get this thing. But inside this I am just writing a single line of code. I'm just writing a single line of code, right? So there you have it, right? You can do this in a single line, So this is one of the ways you could use a for loop, or you could have used this is positive function as another example. This would have taken a little bit less line of code, but instead you used lambda function and you solved it in a single line. Boom. Now here's the magic, right? See, you get the same thing again, just using a single line. That's the power of Python inbuilt functions. So that's how I demonstrated filter function. Now let's move on to our next topic, which is, well, map functions. Now map is written like this, map. Again, you can see this. The first argument is the function, and then anything iterable. Again, iterable is a tuple, list, set, whatever. Now here you will pass the function. You won't call it, you will just refer it. So do not put this thing here. Okay, and then you say function, and then you say iterables. Okay, so this is the function. This is how you call map function. Remember that. Now again, if you just use map function, you won't get a list or tuple or anything. You have to use list. Okay, remember that. You have to use list or tuple or set, whatever you like. Now what is map? Map is basically, well, let me give you a demo. You know, I have already told you what a map does. Now I'm gonna show you in live. So this is a map thing, and you say int, and you're gonna pass a list which has 1.89, 5.98, 6.55, 4.32. So these are all float numbers. We are passing it, and let's see what happens. And again, we need a list outside map. List, put a bracket in here. Let's see what we get. So we get 1, 5, 6, and 4. So all the float numbers, all the decimal numbers are converted into integers. How? Because inside map, the first thing we are passing is int, and then the second thing we are passing is the iterable we need to change. So basically map is doing, what map is doing is, map is taking every element which is present inside the list. It is taking every element inside the list, and it is passing this thing to this function. Okay, and you know what an int function does, right? I don't need to repeat it again. Int function converts anything to integer, any number to integer. It can be float, it can be whatever, but it converts it into integer. Remember, it can be string, it can be converted into integer. You have seen how an int function works. So what map does is, it takes the first element 1.89, it passes to int. Now 1.89 becomes 1. Now it takes the second element. So basically this is just like a for loop. This is just like a for loop where you are going through every element of the collection or the iterable. Okay, now it takes the second element, it converts 5.98 to 5. Then it goes 6.55, takes it, puts it into here. Now 6.55 is converted into 6. Finally it takes this thing and it puts into integer, and it converted into 4. So the only function of map is to perform the same operation on every element of a given list or given tuple or a given set or any iterable. Okay, so that is the main purpose of map. The main purpose of map is to perform the same action on every element of the given iterable. So again, we can replace this using a lambda function. And now since you guys know how to write a lambda functions, I won't go with the traditional functions, although you can call it. So okay, let's give you a traditional example. Def, and you say square. Okay, so you say square, and inside square you take a num and you return whatever there is num square. So that's what you do, right? Now just take this thing, okay, not this thing. Let's have a map will give, and the first thing you are going to pass is the name of the function, and it is square, and the next thing you are going to pass is the list. Let's say 2, 4, 5, 8. Let's see what happens. And if I just hit enter, it won't work because it will give you map object. It cannot directly print on to the screen. Is to put a list, and inside this list just put the same thing and see if it works or not. Boom. So the square of 2 is 4, the square of 4 is 16, the square of 5 is 25, and the square of 8 is 64. Okay, and how we are getting this? We are taking every element present in the list and we are passing it to this function. So the map function takes this out, puts it into here, and we simply return num square. So 2 square is 4, 4 square is 16, 25 square is 5 square is 25, 8 square is 64. So basically what's happening is, it is taking every element present in the list or collection, and it is passing it to this value, this function, and now this function is converting it is returning the square of the given element. Again, we do not need to write the function. We can simply use a lambda function here because this is a pretty simple task. We do not really need a function to do it. We can say, we can just put this thing. Let's copy this thing, paste it here, and just remove this square. And you guessed it right, lambda num, because we were passing num. So basically, this num is same as this num. The only difference is that this has a name and this doesn't, because we don't really need it again, right? So lambda num, and what you are going to do is num 2. So we are returning this thing. Okay, now let's see if this works or not. See, it works perfectly fine. And don't you think this is more simple, right? So you're doing the same thing. Okay, you do not need to write any return statement, you do not need to write anything, you're just doing this thing and you are getting it all. And lambda functions will prove to be more useful when you are sorting a list of dictionary, you're working with dictionaries and many complex data structures. And I will show you in the next video where I will be sorting dictionaries and working with dictionaries, and how lambda functions prove to be very useful for complex data structures. So that's how you work with lambda functions, right? Now let's say you want to convert every element inside this to, well, let's say, what can I say? Okay, let's do something else. Okay, I want to reverse the number. So what can we do? So I can say list and say map and lambda num str num, and again we use the simple trick, which is colon colon -1. If you do not know what this means, this basically means we take a negative step. But we do not mention any start or end. And if we do this for a string, the string gets reversed. And you might say that num is a number, but as you can see, we are using string function here, so we are converting the num into a string and we are returning it. So let's see what happens. We pass the numbers as 567, 123, 415, 450, or not 0, 459. Let's see what happens. So you can see what is happening. Oops. Well, yeah, it works, but I need to convert it back into integer. Well, 567 is converted into 765. 123 is converting into 321. And 459 is converting into 954. So basically these are reverse numbers. And again, I need to make a small change here. As you can see, there are these single quotes. That means these are not integers, these are strings. So we need to convert it. How we can do it? Again, we will use int. So we will say int, and we just convert the whole thing into integer. Boom, we have it. So now let's understand the logic here. So we are taking 567. So this is the first element. We are taking it and we are passing this into this lambda function. So now the present value of num is 567 and this is an integer. Now what's happening is we are converting this number into string, then we are reversing it, and then we are again converting it back into integer, and then we are returning this. That is what happening. So 567 is converted into string of 567, then it is converted, then it is reversed. So reverse version is 765. So 765, and then it is converted into integer. So now it is no more a string, it is an integer, and then we are returning it. So basically 567 is the first element, so it is converted into 765. Then 123 is the next element, again it is converted into string, it is reversed, and then it is again converted back into integer, then it is returned. We get 321, and finally we get 459 as 954. So that's how map function works. Now let's have a practical implementation of map. So in competitive programming websites, for example, HackerRank, HackerEarth, Coding Wars, or coding games, exorcism.io, or anything like that, it sometimes requires you to give multiple values in a single input. Okay, and what do I mean by this? I mean that in a single line of input you will say it's a 70, 80, 90, 100. Okay, so this is a single input, but in reality you are giving four inputs: this one, and this one, finally 70. So there are four values, but in a single input. Okay, now how can we split it? Because this is a string, right? Okay, let's take an example. So we have a variable called x, and I say input, and I enter 70, 80, 90, 100. Now what is the value of x? So the value of x is a single string, and we need to convert it into a list of these elements. So there are four elements, so we need a list of four elements: 70, 80, 90, 100. And how can we do that? We will split it. We will split it because we know that there is a separation between every element using a space. Look at these spaces. So we can safely conclude that if I use split method, it will give us a list which consists of four elements. So if I say x equals to input dot split, because this is a string, and we are basically saying string dot split, so we are making it a list. We are breaking it and then converting it into a list. So now if I say 70, 80, 90, 100, let's see what that gives us. Now let's check the value of x. As you can see, the input has been converted into a list with four elements, because these were the elements 70, 80, 90, 100. So what is happening is, we give this input, we are giving this input, it is basically this thing is replaced by this thing, and after that we say dot split, and whenever we say this, it breaks it into four pieces, because there are four elements are separated using spaces, right? So that means we get a list. Now there is a problem, and can you identify that problem? The problem is, whatever we take as input, by default it is a string, and we need to convert it into integer. Okay, and we cannot directly say like this, that x equals to, then we say int, and then we say input dot split, and this will generate a error. You want to see? Just see this. Let's say 50, 60, 70, 80, 90. It gives you an error. Why? It says int argument must be a string, a byte size object, or a number, not list. Right? Why not list? Because this is a string, this method converts it into a list, and the int function cannot be directly used on a list, on a complete list. Okay, it can be used on the individual elements of a list, but it cannot be used on the whole list. Okay, so it cannot be used on this list. You want to see? Let's copy this, and let's say int, and we paste this here. See, it will again give this error. Again it is giving this error. Why? Because this is a whole list, it cannot work on that. Int will work on this, 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 and this. Now since we know that there are two ways of doing this, let's have another list called new list. Okay, new list, sorry, and original list, or let's say old list. Old list equals to, sorry, let's copy paste this, copy this, and paste this. Okay, so this is our old list. Now again we will use our good old way, which is a for loop. So we say for num in old list, we will say num equals to int num, because we are converting, we can convert a single element into integer without any problem, and then we append it to the old list. So we say old list, I'm sorry, new list, I'm sorry, where we are appending it to this list. We are putting it to this list. So this is a string. I take this, I convert this into integer, then I put that thing into this list. So this is the basic methodology. Now I say new list dot append num, and let's see what happens. Now if I hit new list, let's see what that gives us. So it gives us all the elements in integer type. Okay, so now the quotes are removed. You can see now the quotes are removed. When there were quotes, that means it is a string. This is a string because there are quotes. This is again a string, there are quotes. But you can see there are no quotes. That means this is an integer. So this is our good old way of doing this. You write the you have to make two different lists, then you have to use a for loop to complete this thing. Well, there are lots of lines of code. But what if we can do the same thing in a single line of code? Let's see what happens. So what is our first thing? We need to take an input from the user. Then we will have to break it into multiple parts. Then we have to convert every element into integer, right? So this is our task, and we can achieve it using map function. So we will say x equals to map. Inside map, the first argument we passed is the function that will convert each one of them. It will go through each one of them and convert it into integer. And what is that function? Int, right? Because int can take one value at a time, right? And that's why it is okay. So this is the function, and we are going to use that on every element of the list. So what is our list? Old list, right? Or just forget it. Just forget it. Let's take it from the very beginning. Let's say input dot split, right? And then since map cannot directly show it, we will use a list function outside it. Okay. Now see what's happening. We are first taking an input from the user. We are breaking it into several pieces. After that, what map function does is it takes every element from this list, because this will return a list of strings, and every string is passed into this function. Now this function will convert each one of them into integer and it will return it. And then we have our new list. Let's see how that works. 50, 60, 70, 80, 90. Now let's see what happens. Now let's check the contents of x. Boom. So we can see that all the elements are in integer. Now let's check again. We have taken the input. This was our input. After that, we have broken it into this thing, this list. After that, this map function takes each one of them, puts it into integer. Integer converts it into integer from string, and then it gives it back. And now map keeps it, right? And then we make a list out of it. So for the first element, 70 is a string. Map takes it, gives it to integer function. Integer converts this string into a number, then gives us back. We keep it. Then it goes to 80, takes 80 and passes it into integer. Now 80 is converted into a number, then map function keeps it. Like this, it continues till 100. Okay, and then we make a new list out of it. And that's how it works. Now let's come to our next function, which is reduce. Now what is reduce? For that, I need to show you something. I need to open my paint, and I need to show you the functionality of reduce. Okay, so let me open paint for that. So we have a list of elements. Okay, so we have, let me take the font here. Yep, and I need to make it a little bit bigger, and I make it, let's say 32. 32 is okay. No, did my computer just hanged? Well, 26 is okay, right? Yep, I think that's perfect. Now let's have a list of elements, which is 1. Okay, let's start from 2, 4. Okay, not 2, 3, 4, and 5. Okay, so these are our elements, and not 5. Let's take 6. Okay, perfect. So these are our elements. Now we have a function. We have a function which adds two numbers. Listen very carefully because this is very important. We have a function like this, and I am writing lambda functions. You can write your, your old good traditional functions, but I will recommend you to use lambda functions whenever you are using map, filter, and all these methods. I'm sorry, functions. Lambda a b. So these are the two numbers, and you are saying a plus b. Okay, that's what you are doing. So this is our function. Let's take a brush. So this is our function, and we are using reduce function. And as I already told you, reduce does the same job like a map. Okay, reduce is very similar to map, but the only difference is that map will give you a list or a tuple or multiple values. But the main difference between map and reduce is that reduce will give you only a single result. Remember that reduce will give you a single result, right? So how many values are there? How many values are there? 1, 2, 3, 4, 5. So there are 5 values. So if I use reduce, what reduce will do is it will take each one of them into this. Okay, each one of them into this, and okay, just let me draw this one, and it will give me a single value, and that value is currently unknown. And this is the basic functionality of reduce. It will take multiple values and it will give you only one value, only a single value. Remember that. Okay, it may be an integer, it may be a string, whatever it may be, it gives us a single value. Now let's control Z all of these. Right now, let's say I write something like, okay, how to write reduce. Reduce is written like this. Reduce. Okay, for reduce you need to import reduce. You cannot directly use reduce. Okay, you cannot directly use reduce. You need to import it. From where? From a module called func tools. So you can say from func tools import reduce. Okay, so now you can use reduce. Now you say reduce, and you have a function called lambda a comma b colon a plus b. So it adds two numbers. That's it. And you give a list which consists of 2, 4, 2, 3, 4, 5. I guess that was it, right? 2, 3, 4, 5, 6. Okay. One another number, 6. Perfect. Now let's see what that gives us. 20. Now why is it 20? We need to look at that. Why does it give us 20? So this is our expression. Let's write it. Let's write it. Control C it and take a font here. Peekaboom. Make it a little bit longer. Paste it. So this is our function. Okay, this is our function, and there are two parts of it. Let me just copy this thing. Or just control Z. I'm sorry, control Y. Just select it. Now select this one. Okay. So there are two parts of the function, right? Let me take a blue color for that. So there are two parts of the function. Let's take the brush. So what are the two parts? This is the function, the left one is the function. Okay, the left one is the function and the right one is the iterable. Okay, and iterable has many elements. So what reduce will do is that it will take every element of the list or iterable and put it into this. Okay, and it will keep on doing this because I told you that this is basically just a map function, just like a map function, but it will give you only a single value. So it will take all the elements from the list and it will keep on putting it into this function, and this function will return some value. And what is that value? That value is a plus b. Okay, that value is a plus b. Now for better understanding, let's write this again. So let's copy this thing. Let's have something like this. And this time let's use some other color. Let's say we use purple this time. Purple is a good color, right? Don't you agree? 2, 3, 4, 5, and 6. And let's give a little bit of space between them because I need to draw something. Okay, that's perfectly fine. Now let's take a brush. Let's take a red color. Now let's get started. So the first element which is passed into this function, this lambda a comma b, a plus b function, okay, this function is 2, right? The first element is 2. So the current value of a is 2. Now what is b? B is obviously the next value, that means b is 3. So a is 2, b is 3. So a plus b gives us 5, right? So we basically do, we take 2 as a, 3 as b, a and b, and we add it. And what do we get? We get 5. Okay, we get 5. Now this 5 is our new a. This 5 is our new a. And what is our b? This is our b. Okay, this is our b. Now again we add it. What do we get? We get a plus b, that is 5 plus 4 equals to 9. Again this is our new a. This is our new a. And now what is our b? B is our 5. The next element is the b. This is our b. Now again a plus b. A plus b gives us 14, right? So we get 14. And finally this is our a. Now what is the next element? It is 6. So this is our b. So you can see that it works like a tree, right? Now this is a b. So a plus b gives us 20. Now is there any other value? Check if there is another value. So since there are no more values present, this is our final answer. And we can check that using this thing. Okay, see, we got 20. Why? Because 2 plus 3 5, 5 plus 4 9, 9 plus 5 14, 14 plus 6 20. That's it. That's how reduce function works. Reduce, now look at this. Reduce took 5 values, right? 2, 3, 4, 5, 6, and it gives us only a single value, which is 20. Now that is the purpose of reduce function. Now that's how. And did you notice that 6 plus 5, it will give you 11, then 4, 15, 13, 14, 15, 16, 17. Okay, now what will happen if we add this thing? What will happen if we add this thing? Let's check what happens. So let's say sum, and basically we give the same numbers, 2, 3, 4, 5, and 6. I'm sorry, this must be a list. We get 20. So now do you notice that sum of all the elements and this thing over here is same? That's how sum function works. Some in inside some uses this thing, lambda a comma b, where it gives you a plus b and it ultimately gives you reduce function. Now similarly you can just do average function, you can do something on your own. Okay, and that's how interesting it is. Now let's take some other examples of reduce. Now let's say reduce lambda a square, and then pass this list 1 2 3. What happened? Lambda takes one positional argument but two were given. Why? So you got this error because you had passed only a single value to lambda. Now in case of reduce function, the goal is to give you a single value. The goal is to give you a single value. But when you are doing this, when you are doing a square, this is basically a square, it cannot give you a single value because 1 square is 1, 2 square is 4, and 3 square is 9. But they are three different values, right? It cannot give you a single value, and this is the reason reduce function does not work here. Okay, now that is the concept. So the main purpose of reduce function is to give you a single value. So remember that. Do not use these lambda functions where you actually do not calculate anything. You just return a single value. This won't work in reduce function. So what is the another function? Let's take another valid example. So reduce, you say lambda um and you take a comma b, where you multiply, or let's say you divide a with 2, or you just divide a with 2 and add it with, okay, this will be very complex, so just a multiplied by b, and you take the list as 1 2 3. Now let's see what happens. It gives you 6. Why? 1 multiplied by 2 gives you 2, and 2 multiplied by 3 gives you 6, right? Now let's take another example here. Okay, let's remove this whole thing and let's take another example here. Okay, now it will again give you the tree structure, so delete it, start from the very beginning. So what is our expression? Our expression is, let me write this one. So I say lambda, I'm sorry, not lambda, reduce, and you say lambda a comma b, and you say a multiplied by b, and then you pass something as list of 1 2 3 4 5 6. Okay, let's keep it big. You pass 6. Okay, so what are the two different parts? The two different parts are this is the function. Okay, let's take the brush. This is the function that we want to use. This is the list on which we want to use this function. So every element of this list will be passed into this function, and ultimately, you know two of the values will be passed into this function. Okay, where one is a and two is b. Let's just control z this one, and yeah, one is passed as a, two is passed as b. Okay, so that is our initial value, right? So these are our two parts. The first part is our function, and our second part is the iterable, where we are going to use that function. Now let's take the example. Let's see what this gives us. Let's take the previous thing and let's add 4. Okay, it gives us 720. Now this is a pretty big number, so let's see what happens. Okay, now we take a list here, and we'll take a green here, and our first element is 1, then 2, then 3, then 4, then 5 and 6. Okay, now add one extra space here. Okay, that is perfect. Let's make it a little bit longer so that we can work properly. Now look at this. I will take a line for this purpose because that will make more sense. So this is our A, and let's not take green. Let's take red for this purpose. So this is our A. Damn. A. And for B we take blue. For now take blue. This is for B. This is our B. This is our A and B, right? So red is for A, blue is for B, and what it gives us 1 multiplied by 2, because see there is a multiply between them, A multiplied by B. So that gives us, let's take black. So 1 multiplied by 2 gives us 2, right? So this is our new A. This is our new A. And then again, let's take this thing, make it a little bit smaller. Yep, that is okay. Now take this away. Yep, and put this into here. Okay, done, right? And now what is our new A? This is 2, right? And this is our new A. So again 2 is our new A. And what is our new B? Our new B is 3. So we take 3 as the new B. So our current B is 2 multiplied by 3, which gives us 6. Not this one. Let's take black. And it gives us 6. So this is our new A. Again, let's take red. And let's take a line here. And again, this is our new A. So let's draw the line. And then what is our blue? Our new blue is this one, this 4 over here. Oops. Okay. So 4 multiplied by 6 gives us 24. Right. Now 6 multiplied by 4 gives us 24. So let's take that one. 24. Right. And then again take a line here. So what is our new A? Our new A is 24. Right. And what is our new B? Our new B is 5. So let's take that one. And 24 multiplied by 5 gives us 120. And we say 120. Perfect. And finally our new A is 120 and our new B is 6, right? So I take this one, this line over here. Finally, Control Z. Dude, this is not working. And now what is our new B? Our new B is 6. So I take this one. And 6 multiplied by 120, final answer is 720, right? So our final answer is 720. Okay, and that's how our reduce function gives us a single value. It takes all these different values 1 2 3 4 5 6 and it gives us a single value which is 720. That is the function of, that is the main functionality of reduce function. So that was our reduce function. Now let's take all of that into together. I want to say that let's take reduce, um, and then inside reduce we will use map, and inside map we will use filter. Looks pretty complex, right? Well, it is not. Now let's take another example and it will be all clear. Okay, let's remove this whole thing. Control A this, Control A this, Control A, and delete. Okay, perfect. Now time to take another example. So let's have a list of elements. Let's have a list of elements here, and I will keep it simple, so don't worry. Let's keep it this time. Let's keep it 20. 20 is perfect. Not this one. Let's take black. Right. So our values are 1, 2, 3, 4, and 5, and 6. Right. And also 7, and 8, and 9, and 10. So these are our values. Now what we will do is we will use a filter function. So we will write basically this piece of code here. We will say filter, and inside filter we will say lambda, we will say x, and we will say x more than x less than equals to 4. Then the next argument that we pass is this list. Okay, and the name of this list is let's say values. Okay, right. So this is our filter function here, and let's rename this. So basically we are saying values equals to this one. Okay, now let's take an arrow here. So we pass this value into this thing, right? Now let's check what happens. So filter function does what filter function does is that it filters the values according to the given condition, right? So what is happening here is that it is taking every element of this list present over here, and it is putting all these elements into this function, and this function either returns true or false. If this function returns true, we keep the value. If this function returns false, we throw the value, right? Now this function says lambda x, where x is less than equals to 4. So what are the values that are less or equal to 4? That means 1, 2, 3, and 4. That means up to this. So these are the 4 numbers that satisfies this condition, right? So boom. That means our new values is this one. Let me write this again. So our new values is 1, 2, 3, and 4. Okay, so this is our new list. Why? Because the filter function has filtered these 4 values, so these values are not present. Okay, let's cut them. They are not no more present, because filter function applied this function, and this function returned true for only these values, because 5 6 7 8 9 and 10 are more than 4. That means it does not satisfy this condition. That's why it returns a big false, and when the function returns false for a particular value, the filter function throws them away, right? So our new list is 1 2 3 and 4. Now we write another function. Which is our map function. Okay, let's write it. And we say map, and we say lambda x x square, right? X square, and we basically put this thing. So we are putting layer after layer, remember that. So filter lambda x, where x is less than equals to 4 values, and let's make this a little bit longer. Perfect. And let's shift it to here. Yeah. Now look at this very carefully. So don't worry about this part, because this is this part only. Okay, do not worry this. So basically it is a layer. This is the first layer, filter is the first layer, map is the second layer. So what does the first layer returns? This is what is passed inside this. Okay, right? So this is replaced with this one, because we already did this, right? We already did this, and it returned us this thing. That means our new values are this. Okay, now we say lambda x, where x equal to where x square, right? Where we are returning the square of every number. So what are our new values? So for every element we are going to calculate the square of the number, and we are making a new list out of it. So our new values are, and our 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16, right? These are our new values. Why? Because we have calculated the square of every number. You can see, and that means we are going to put another arrow here. So we have passed this one, not white, bro, not white. I'm going to take this one as black, 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 and this one also black, black. Yeah, perfect. So we pass 1, 2, 3, and 4 into this function, and this function calculates the square of every number. So 1 square is 1, 2 square is 4, 3 square is 9, and 16, I'm sorry, 4 square is 16, right? So these are our new values. And finally we put another layer. Which is our reduce function, and we write another function. So this will be longer. And we say, and let's make this little book longer. Yep, it is perfect. Now let's write reduce. Let's take the red color, because for every function we are taking the red color. Yeah, now we see reduce, and inside reduce we say lambda x comma y, x plus y. That means it will add both the numbers. And inside that, our next layer is map. Inside map we say, just copying it, lambda x square, and inside that the next layer is filter. So you can see layer 1 is filter, layer 2 is map, and layer 3, which is the final layer, is reduce. So we say lambda x colon x less than equals to 4 and values. So I need to make this a little bit longer. Yep, perfect, right? Now look at this, what happens. Now we pass this thing. Into, you know, one second, just hold on. Select this thing. Okay. We pass this thing into this thing. Now what reduce does is again it repeats what it does, right? So let's take the black thing, black color, black brush, whatever is here. Now 1 plus 4 gives you 5. It gives you 5. 5 is our new A. Now 9 is our new B. So 5 plus 9 gives us 14. Right? 14 is our new A. And now 16 is our new B. So what is 14 plus 16? Calculate. 20, 30, right? It gives you 30. So that means 30 is our new value. Okay. So let's write it. Let's see what happens. We do this. Reduce, and we will keep spaces because spaces make it look clean. Lambda x comma y, where you add x with y. The next layer of now the next argument is basically map function, which is layer 2, and inside map function you say lambda, again let's keep the spaces, lambda x, where x you calculate the square of every number, and inside this the final layer, the lowest layer, is filter function. Inside filter function you again put lambda function. Inside lambda function you say lambda x, and you calculate, you keep all those numbers that are less than or equals to 4 for this list. 1 2 3 4. Okay, 1 2 3 4, right? Or no, not 1 2 3 4, actually 1 2 3 4 5 6 7 8 9 and 10. Now let's see what happens. So you can see it gives us 30, right? How can we get 30? This is the first layer. This is the first layer. Now what it does is it removes all these numbers. So our new value is 1 2 3 4. So this part is done. So we are done with this thing. Now what is the next part? Map function. Map function says just calculate the square of every number inside the list. Now what is our new list? So since this whole part is replaced by only these 4 numbers. So our first number is 1, second number is 2, third number is 3, and final number is 4. And we calculate the squares as 1 square as 1, 2 square is 4, 3 square is 9, and 4 square is 16. And that is our new list. So we are done with this part also, right? This whole part we are done with this. And so our new numbers are 1, 4, 9, and 16. Now reduce function says add 2 numbers. Now our first number is 1, second number is 4, 5. We add them and we get 5. And our next number is 9. We add 5 with 9, we get 14. And our final number is 16. We add 14 with 16, we get 30. And thus we get our result, right? So this is the lowest layer where we actually filter our values. This is the next layer where we calculate new values. And this is our final layer where we get one value out of many values, right? So you can see we just added things into this, right? So let me take blue color for this one. So filter function is added into map function. Map function is added into reduce function, right? So this is layer 1, this is layer 2, and this is the final layer. And that's how we can use reduce along with map along with filter together, right? You can do this, and if you face any doubts, I am there for you. Just ask me and I will help you. Okay, I guess it is clear, right? Okay, now we are done with the most important functions of the Python module. Now let's move on to some the last two functions, which is all and any. So let's say we have a function all, and we pass a value true, true, true. It gives true, right? But if I say true, true, false, it gives us false. I say false, 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 it gives us false, right? And there is another function called any, and inside any I say true, 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 and it gives us oops, this one, just remove this one. Yep. True, right? So for all, if all the elements in any are true, then it gives us true. But let's say we make one of the elements as false. Now see what happens. True. Still we are getting a true. So this is basically like a OR gate, or OR operation in Python. Again give a false, again true. Let's make all of these false. This is the only case where any will give you false. So this is the function. If all the elements in a given list are true, then only any will, then only all function will return true. See here, all the elements are true and all is returning true. But even if a single one of them becomes false, it will give false no matter what. Okay, so this is the only condition where it will give you true. And in case of any will keep on returning true as long as there is at least one element which is true. So all of them are true, it gives you true. Two of them are true, it again gives you true. Only one of them is true, it again gives you true. This is the only case when it will give you false, when all the elements of the given list is false, right? Now let's take some of the practical examples. Let's say I want to check if a given number of, if a given list has all positive numbers. So we can use list comprehensions for that. We say x more than 0. This is list comprehensions for x in, okay. So we have a list, let's say num list. So this is our list where we pass some of the elements 1, 3, 5, 40, -1, minus let's say 111, minus 6, 50, 56, 0, and 45, 67. So this is our number list. So there are positive numbers, there are negative numbers, there is a 0, right? It is mixed of all numbers. Now let's say we use um you know let's use any function, any, or let's say let's use any function. So we check this any function. We say x more than 0 for x in num list. Let's see what that gives us. So we say this, let's see what happens. It gives you true. Why? Again, this is a comparison, remember this. So this is a for loop. We are using list comprehensions, although we are not using any list. Of course you can say like this. You know what list comprehensions are, right? So you get true. You can remove this as per your wish, because eventually this will return you a list only. Okay, you can see this for yourself. Let's see what happens if I write this only, remove this thing. Okay, so you must use these, at least these, or these brackets. Okay, see, it gives you an object, although you cannot directly view it, of course. You can use tuple function for this, so you can see this. So just look at this, what happening. Or better if you use list function for this one. So what is happening here? You are basically using list comprehension. You are saying for x in num list, that means you are going through each one of them in this list, and you are making a comparison here, x more than 0. So for 1 it is more than 0, that's why you get a true, because a comparison will either give you true or false. Okay, that is the basics of comparison. Comparison may only give two value. It may give true, it may give false, that's it. So we check is x is more than 0 or not. So for the first element 1 is more than 0, so we get a true. For the next element 3, again 3 is more than 0, we get a true. Again 5 is more than 0, we get a true. 40 is more than 0, we get a true. Minus 1 is not satisfying this condition, so we will get a false, because -1 is not more than 0, it is less than 0, so false. -111, it is not more than 0, false. -56, it is again not more than 0, false. 0, it is again not more than 0, 0 is equal to 0, not more than 0, we get false. 45 is more than 0, we get a true. And 67 is more than 0, we get a true again, right? So that's how you can use list comprehensions for comparison. Now you say any, you do the same thing basically, and just keep it any, see what happens. It gives you true. Why? Because there is at least one element which is true. If and only if all the elements in this list are false, then only it will give you false, otherwise it will give you true, right? So this is the reason it is giving you true. But in case of all, let's see what happens if we check all. It gives you false. Why? Even even there is only one false in the list, it will give you false. It has to be true. All the elements in a list or a tuple has to be true. Okay, in order to in order for the all function to give you true. So any means check if any of the number is more than 0, and all is check if all the numbers are more than 0. Okay, so this is our any and all, right? Any, all, remember this, right? So that was our all the our all the basic built-in functions of Python, along with the reduce functions, which is not a built-in but it is a very useful function, right? And I hope you guys understood it. Any will give you true if at least one of them is true. All will give you false even if one of them is false, right? Now let's take some of the other examples also. You can skip the rest of the video because if you have understood it, so you don't need to watch it more. Now let's take another example. We have a list. Let's say any. Inside any you say x less than equals to, well, 10. For x in, let's pass a list, and you say -1, -2, -3, or just keep it on. Let's take it 50, 60, 70. Let's see what happens. Any gives you false. Why? Because the condition is x must be less than or equal to 10. But in this list all are more than 10. 50 is more than 10, 60 is more than 10, 70 is again more than 10. So that is the reason you get all false, right? You can check this using this list function here. So you can see that all of them are false. But if you slightly change only a single value, which is, let's keep it 5. Okay, it gives you true. Now if you use any function, it will give you true because at least one of them is true, right? But if you do the same thing for all function, let's see what happens, and just copy this. Say it gives you false. Why? Because there is at least one element which is false. Okay, so it takes only one element to be false in order for the all function to give you false. All of them has to be, it must be true in order for this function to give you true. So if I say something like this, 5 0 and 2, only then it will give you true, right? So these are the basics of some of the built-in functions and some of the important other functions and lambda functions. Now let's open the camera. Let me show you my pretty face. Hi, phew, dude. It took a really long time to make this video. So now since the video is completed, now it will take some time to compress it, edit it, upload it. There are several parts of the video. This video is, a 6-part video, so I have to cut them, join them, edit them properly. Then I have to process them, and lots of work are there. So I will upload it and see you in the next video. I hope you understood it. And in the next video I will cover dictionary, the final and one of the very important built-in data structure of Python. So that will be our last foundational data structure of Python, and after that I will see that if I can complete iter tools or collections, I will cover it. Okay, so our Python basics are almost finished. You are only one video away from finishing all the essentials which a Python programmer requires. And I told you last day, start coding in HackerRank, start coding in all the different platforms that are available, and you can improve your skills by a vast level. Okay, so go and start coding because this is the time you can improve yourself. And okay, see you in the next video. Till then, bye, namaste.